Okay, so what we're talking about here is if you have a deck of cards, and if you know a deck of cards, you know it has 52 cards in it if you remove the joker. So here's the question we're thinking about, okay? You shuffle the deck a few times, and now the deck is in some order, right? It's in some order. Maybe the first card's the 3 of clubs, the second card's the king of spades, on down to the last card. Now let's say we shuffle it again. Shuffle it again. Now the deck of cards is in a different order, right? Very likely. We shuffle it again, now it's in a third order, right? So the question that we're trying to answer is how many different orders can there be, right? Okay, so the answer is actually not that difficult to calculate, and here's how you do it. You actually take 52 and multiply it by 51 and multiply it by 50, and then multiply it by 49 and 48 and 47, etc., down until you get times 3, times 2, and times 1. So we know how to calculate it, and in fact, you can ask a super calculator like Wolfram Alpha or something to calculate it for you. So here it is. Here's the expression. It's 52 factorial, it's called. And you just do 52 times 51 times 50, etc. And when you do it out, you get a massive number. You get this number. I think it has 58 digits in it. And I mean, it's huge. I mean, but the question here is that we're trying to get at is how big is this? You know, obviously it's massive, but we don't really have the capability to imagine. So this guy online came up with this way to kind of understand how big this is that just literally blew my mind. So I'm going to try to explain it. So here's how this guy explained how to do it. So instead of imagining that number as the number of different ways you can arrange a deck of cards, imagine that it's a number of seconds. Okay, so we're going to set our timer to that number of seconds, this huge number right here. We set the timer for this number of seconds, and we're going to hit go, and we're going to wait until it goes down like a timer. And the question is, how long is that going to take? Obviously, the answer is a long time. But this guy came up with an algorithm to pass the time. So let's go through the motions of this guy's algorithm for passing the time. So here's what you do. First, you go to the equator, right? You're going to walk on the equator, eventually around the whole world. And you take your stopwatch, you set it for that huge number of seconds, and you press go. Now, step 1 of this guy's procedure is wait 1 billion years. 1 billion years. And after that 1 billion years, you take a single step. And now you wait another billion years, and you take another single step. And now you wait another billion years, and you take another single step. You do that until you get all the way around the Earth, at which time you reach down into the Pacific Ocean. You pull out a single drop of water, like a raindrop, and remove it from the Pacific Ocean. And now, repeat. Wait another billion years, take a single step around the equator. Wait another billion years, take a single step around the equator. Do that until you get all the way around, reach down, take out another single raindrop from the Pacific Ocean. Repeat. Take one single step, wait another billion years, take another single step all the way around and then remove another raindrop from the Pacific Ocean until the Pacific Ocean is completely empty. And then take a single sheet of paper and place it on the ground. Now, repeat. Go back to the equator, fill up the Pacific Ocean. Wait a billion years, take a single step. Wait a billion years, take a single step. When you get around, take a single drop of water out of the Pacific Ocean again. Do it again, another single drop until the Pacific Ocean is empty again. Now take a single sheet of paper and place it on top of the first one you put. Now repeat again. Around the earth, removing single raindrops. Add a third piece of paper to your stack. Now you've got a stack of paper that's 3 high. Do that until that stack of paper reaches the sun. And we're not even close. Now topple the paper stack down and start all over again. Equator, single step, billion years, single step, single drop of water, till you get a single sheet of paper, single sheet of paper, single sheet of paper, stack it to the sun again. Not even close. Do that paper stack to the sun 1,000 times, and we're not even close. But we are bored. So he switches the routine at that point. So we're done with that paper stack. It's quite boring. So here's what we're going to do. Instead of that, we're going to take on a new technique. We're going to take a deck of cards and we're going to shuffle it up, shuffle it up, shuffle it up. And now we're going to wait 1 billion years. And then we're going to deal ourselves a 5-card hand off the top. And we're going to see if we get a royal flush. We're not going to get a royal flush because a royal flush is a very rare hand to get. So when we see that we don't have a royal flush, we put the cards back in and shuffle again and wait another 1 billion years. Then we deal ourselves a 5-card hand. See if we get a royal flush again. We're not going to get the royal flush. So we put it back in, wait another 1 billion years. It's like a 1 in a million chance to get a royal flush. So you deal yourself 5-card hands every 1 billion years until you get a royal flush, at which point you buy a lottery ticket and see if you win the lottery. You won't. Start over. Deal yourself 5-card hands, don't get a royal flush, wait 1 billion years. Deal yourself 5-card hand, see if you get a royal flush, you don't, wait another 1 billion years. 1 billion years later, you get another royal flush, you buy a second lottery ticket and see if you win. You won't. Do it all again. Do it again, do it again, until you win the lottery using that procedure. At which point, you take a single grain of sand and drop it into the Grand Canyon. Start over. Deal yourself a 5-card hand. See if it's a royal flush. It's not. Do it over again until you get a lottery ticket. You won't win. Do that again until you win the lottery again. Drop a second grain of sand in the Grand Canyon. Do that until the Grand Canyon is filled to the brim everywhere with sand. And then go over to Mount Everest and remove a single pebble. Repeat. Empty the Grand Canyon. Start dealing yourself hands. Try to win the lottery again. Fill the Grand Canyon to the brim again. Remove another pebble. Do that until Mount Everest is flattened to the ground, and we're not even close. We're not even close. In fact, you have to level Mount Everest 256 times after stacking that stack of papers to the sun 1,000 times, and then the timer will go off. Beep, 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 beep. That's how many ways you can organize and arrange a 52-card deck. In fact, they say that if you give a deck of cards a few good shuffles, the order that that deck is in is almost certainly never been in that order in the history of cards. Blew my mind.